Log on, tune in, find out. Another good idea from Cambridge.
So if nothing was switched off here, nothing should be switched on again. Do you hear me? Okay. So my name is Andrei Bejan. I'm currently in the Stats lab here in Cambridge, working on studying uncertainties of future energy systems. There's not so much work produced there yet, and speaking of my background, I did PhD a couple of years ago, finished on percolation and experimental design, Bayesian experimental design for percolation and random graph models. And in fact, just maybe a couple of months ago, within the experimental design of an analysis of experiments program, I gave a talk here at this institute. But in 2009-2010, I've been working with computer scientists in the computer lab here in Cambridge, and we've been looking at vehicular transport traffic data. So one aspect of which was how to use static and mobile infrastructure, sensor infrastructure, in order to study congestion or traffic patterns. And so today, I would like to take you through the part of our work where we use the concept of velocity fields, and the velocity fields were derived from the public transport data, with the use of crowdsourced maps, which gave us additional information on the top of the road network topology, additional information about the road network infrastructure. So what we have been able to say about congestion and traffic patterns. Okay, but before I move on, I would like to start with this heat map, which I'm telling you claims that, so you can see Cambridge, you can see its areas, Cherry Hinton, Trampington, you can see villages around Milton, Histon, Girton in the north, Madingley, Bar Hill, Colton, and each node on the road network is colored according to this plot claims to the travel time which takes to get from that point to the center of Cambridge, specifically County Council location. So I would like to ask, well, those of you who are familiar with Cambridge, how credible is this plot? What do you make of it?
Certainly moderately credible.
Huh?
Certainly moderately credible.
Yeah. So this plot claims that if you, I'm specifically, I'm telling you for which day. Is it a typical pattern? So I picked a day last year. I produced this plot, and I'm going to explain you how I did that. And this plot claims that if you want to come to the county council by 10 a.m. in the morning, that's how long it will take you. So for people who are familiar with Cambridge, yes, please.
What's the mode of transport?
A car.
Oh,
Okay, very good. Yes, by car. So what do you say?
It seems to say, for example, that it takes 15 minutes to get from Humberton to Barton, which definitely isn't true.
So the travel times here are overestimated. Are they not? So for example, if you live in Histon, this plot tells you that. Oh, actually, if you live in Histon, this plot tells you need from 20 to 30 minutes. 20 is realistic for peak times in the morning if you travel towards the city center. But look, there's another interesting feature of this plot, whether it is realistic or not, wherever it makes sense or not. If you look at let me figure out where should I press here. Okay, so if you look here, Bar Hill is very red. And if you look at Cherry Hinton area, or maybe area here, which is sort of at the same distance from the city center, you can see that Bar Hill is much more red than this area. Okay, and you can generally see the northwest region of this map is would take you more time if you happen to travel from there to the center. Okay. This plot indeed corresponds to one day last year, where there was a severe traffic accident on A14. There was a lorry fire early in the morning, and you might remember the day. It was the 22nd of June. And this plot was produced using the velocity fields that we derived from public transport, specifically from buses. So buses carry GPS devices. It is now common practice. The public transport fleets across the country and in other countries are increasingly equipped with location sensors, so GPS devices. And it is so bus companies use them for traffic management, for the fleet management. But in our work, we actually looked at the usage of such data for estimation of traffic patterns and congestion. And of course, one difficulty, the basic idea is actually to look at the buses or taxis, for example, as particles in the whole flow. And one difficulty in using this kind of data for this purpose is that buses use roads in a rather specific way. But if we manage to remove the effects associated with this specific behavior, then perhaps we can still say something meaningful about the traffic and congestion. And another advantage of using this kind of data is that the infrastructure of mobile sensors is already in place, as opposed to the static infrastructure like magnetic loops in the road or cameras that look at the number plates. Okay, so traffic, important for us, and how can we measure traffic? Broadly speaking, we can use such things as travel times or traffic intensity or speeds. So if we look at travel times, this is it's kind of implicit measure of traffic and congestion, where speed profiles may give you more information. So what I'm going to do now is I'll present first of all the travel times. Take Histon, it's a village in the north of Cambridge, and look at all the bus journeys made throughout a year. And I'm not describing here data mining or data fusion problems that we have to struggle with. Only these two plots show you that in terms of travel time, there are effects which are associated with the time of day when you need to travel, and whether it is school term or not. If you look at this picture here in the bottom, so you can see that points in yellow, they correspond to journeys made outside school terms. And look at this dramatic effect of school terms, especially in the morning peak hours. And this is for journeys made towards the city center. The lines here, solid and dashed, are actually quantile regression lines for these two data sets, corresponding to the 10th, 50th, and 90th percentiles. Okay, these are travel times, but perhaps more detailed information could be gathered from looking at speed profiles. And we're using velocity fields for that. Well, velocity fields as a structure, as a function, or as a spatiotemporal structure, as a function that evaluates some kind of aggregated or average velocity at a particular point on the road network at a particular time. Okay. Now, I'll just show you another two examples, and on the left you can see map of Cambridge, on the right as well, but these two maps are snapshots of the velocity fields that we derived from bus data after removing effects due to their specific use of roads, and in a moment I'll describe quickly how we do that. But these two plots show the dramatic effect of the accident which took place here at the Girton interchange for the 22nd of June. And the heat map on the first slide you saw was derived using dynamically changing velocity field derived from bus data. Whereas on the left you can see for the same time, 10 a.m., 15th of June, just a week earlier, that's something that would correspond to a normal pattern velocity field at that time across Cambridge. Okay, perhaps the last most informative slide. So here I show how exactly we actually look at the bus traces and derive velocity information about buses, and then look at how and where buses use the road. For example, buses, of course, use bus stops. They might use bus lanes, or in a unique name, in a prioritized fashion, they might use traffic lights. So if we remove those effects and leave the rest, then maybe that can tell us something about the whole flow. And that's what we're doing here. And specifically, we're taking a bus sample, and the data here are just red points, with rather simple techniques, using monotonic spline interpolation to get the velocity profile. So once the splines are derived, we have an analytic description of the velocity. Then, together with the crowdsourced maps, such as OpenStreetMap, for example, which not only gives information about the road network, but also about the infrastructure of the road, the location of bus lanes, traffic lights, and many other things, we are able actually to produce these velocity fields, which can be thought of something as a table of updates of each of the road segments, its average speed, update time, and then maybe a function, a velocity field transformation, which is kind of aggregation or averaging over time or space or both. Okay, and that's the way we generate velocity fields from bus data. And I would like to finish with not with a summary of what we achieved, but with something that still can be done using this velocity field. And you can see that one problem here is that, okay, so it seems like, and we had a lot of validation studies here, the velocity fields that are generated in this way, they reflect traffic and congestion patterns and the dynamics fairly well. One question that appears here, well, there are two. So the first is how to use velocity fields for characterization of road traffic and classification of congestion levels. That is a question which should be solved probably closely with traffic managers or transport companies. But another question here is that how these structures as velocity fields, how can they be used for fast spotting of accidents and propagation of congestion, so that the road users can be informed in a fast and most informative way. If you have any ideas, or you do have an experience of using this kind of structures, dynamically changing temporal networks, please do let me know. If you have any ideas how to apply this to the velocity fields derived in this way, let me know. Thank you. So the last slide is references, but not for the sake of promotion, but as an acknowledgement of the co-authorship and partnership here. Okay, thank you.
I didn't work with velocity fields. A very simple trick, maybe you know about it. I used Lloyd's index of crowding, where you have but you need count cars that are within a particular distance of each other. Yeah. And that was very sensitive in a simulation model. So we built it in that perspective quite good. And we compared it with speeds, and actually this was you see it very quickly building up. Did you hear about it?
Okay. Yes. You see, counting. Well, there are two problems, at least two problems here. So first of all, when you look at the traffic intensity and flow, the profile is fundamental to the vehicular traffic theory. The profile is parabolic, but it has two phases. So when traffic grows, the intensity then grows, but then it comes down. Another thing is that relies on static infrastructure, in the cameras, detectors. We did investigate these things as well. In fact, we installed our own lamppost on Madingley Road with an infrared camera that sort of preserves privacy, but counts vehicles and estimates their speed. So for various reasons, actually in particular validation purposes.
There's another question in the back. Yes?
I was going to ask a related one. If you had information from the cameras about velocities of traffic, would that improve things compared to just relying on the busing?
Yes, to an extent it would improve things locally, at least locally. How would it improve things globally? I don't know the answer to the question. There is a lot going on currently with so saying something about traffic from just using so-called mobile probes, like taxi GPS, whatever
think
agents
you-
that carry.
For the sort of
GPS
thing you're
device.
after, I think you need information about which routes will be adopted.
Mm.
So, for instance, if you had a blockage at the top of Castle Hill,
Yeah.
before long, that would stop everybody turning off the A14 at the Girton interchange. But it wouldn't stop the people going straight on.
So, just a second, do we have? You might see. So, if you are familiar with A14, you will.
No, the A14 coming in from the east.
Well, A14 connects East Coast with Midland. So,
Yeah.
A14 is this road.
Yeah.
And so, this is also A14. Now, look, this is after the accident happened.
Castle
Do you see
Hill,
this?
which
Alright.
is centre of Cambridge.
Sure.
But there's this near side lane at the Girton interchange which brings you on.
Yeah.
So the people on that near side lane, they will get held up. But the people who are on the outside lane and going through to straight onto the A48, they would.
Well, that information is in the description of the road network, isn't it?
Yeah, but you don't know who are which. You know, you've got your velocity fields, but
Yeah.
you don't know where this car intends to go.
Yes, that's true. And we only have the velocity field for the sub network, which is spanned by buses or mobile probes, whatever they are. Okay.
Sounds good.